Hello, my name is Simaya Kumar Jagannathan, and I'm a Senior Solution Architect at AWS. In this video, we're going to learn about using Lambda layers in .NET. First, we will have a quick introduction of AWS Lambda and then learn about using Lambda layers. Later, we will take a look at how Lambda layers work. We will then go through a demo of creating and publishing Lambda layers in .NET and make use of the Lambda layer in a sample Lambda function. AWS Lambda is a serverless environment that allows you to run your code without provisioning or managing any servers. You just upload the code, and Lambda takes care of everything required to run the code and scales as needed to support high availability. You only pay for the time the Lambda is run in 100 millisecond increments and pay nothing if the Lambda is not running. You can invoke a Lambda through HTTP using Amazon API Gateway or configure various trigger events from other AWS services such as Amazon S3, Amazon SQS, Amazon SNS, and many more. Lambda Layers was introduced in November 2018 during re:Invent conference. It allows you to package a part of your application code into a zip file and upload it as a layer. You can package application dependencies or custom runtime components into a layer and refer the layer in other Lambda functions. Now let's take a look at how Lambda Layers works. Let's assume that there are two Lambda functions called myLambdaFunction1 and myLambdaFunction2, and both Lambda functions use myLoggingLibrary.dll and myExceptionHandlingLibrary.dll library files. When you deploy them to Lambda, they get deployed in separate packages as shown here, along with the common components that get deployed in each one of the Lambda function. Notice the size of each one of the Lambda functions being 3.2 megabytes and 3.5 megabytes respectively, totaling 6.7 megabytes altogether. When you use Lambda layers, you can separate the common components into a layer and only package the application-specific files into their respective packages as shown here. Now look at the size of the application packages being much smaller, and the combined space used by the Lambda functions and the layer is just 3.7 megabytes compared to 6.7 megabytes earlier. Let's take the case of myLambdaFunction1 as an example. When you invoke the Lambda function, the layer components are dynamically pulled and deployed into the bin folder in case of .NET Core being the runtime. For languages like Ruby, Python, Node.js, etc., the layer components are copied to opt folder in the Linux environment. To make this work in .NET, Lambda Layers uses a technique called Runtime Package Store. It is a feature that was introduced in .NET Core 2.0. It basically allows you to package and deploy apps against a known set of packages that exist in the target environment to benefit from faster deployments, lower disk space usage, and improved startup performance in some cases. All you have to do is create an XML file based on this template as shown here. A sample file could look like this. As you might have already noticed, this XML file is based on the typical csproj file structure. Optionally, you could also use a csproj file for this process. Later in the video, we will see how this file is being used to create Lambda layers. Before we see a demo of how to do this in the real world, let's walk through the tools we will use. In addition to installing and configuring AWS CLI, first install the .NET Lambda Global tool. Using this command, which allows us to easily create, test, and deploy Lambda functions. If you already have the tool installed, you need to update it with this command in order to work with Lambda layers. You will also need to install Lambda templates using this command, which will allow you to create Lambda projects easily. Now, I'm on the Ubuntu console using Windows 10. You can also use PowerShell or Windows command prompt for everything that I'm going to show here. I have already installed and configured AWS CLI, .NET Lambda tools, and Lambda templates. Let's create a new Lambda project called Demo Layer using the .NET Lambda CLI. The project will be based on the lambda.empty function template. The project has been created successfully. Let's see the contents inside. You can clearly see that there is a folder called Demo Layer created under SRC, which has the project files. Let's get into it. I'm going to open this folder in VS Code to check the contents. As you can see, this is a simple Lambda function that converts an input string to uppercase and returns the converted string. Let's see the CS proj file of the project to see the NuGet packages that are referenced. As you can see here, there are two NuGet packages that are being referenced in this Lambda function. I'm going to create a new manifest file which I will use to publish the Lambda layer. I'm going to create the manifest.xml file by copying this content and creating a new file and calling it manifest.xml. Now I'm back on the CLI and I'm going to publish a new Lambda layer using the .NET Lambda publish layer command. This will create a new layer and push the layer contents to the Imaya-Lambda layer S3 bucket. Notice that I am also supplying the manifest.xml file as input for the package manifest parameter. The Lambda layer has been published successfully. You can use the .NET Lambda list layers command to list all Lambda layers in your account in the region. As you can see, the demo layer Lambda layer has been created successfully. You can also get the details of the Lambda layer using the .NET Lambda get layer version command. This gives a lot of information about the Lambda layer, like the manifest location, which is the S3 bucket location, whether the packages are optimized or not, and the packages directory as well. This also shows the NuGet packages that are present inside the Lambda layer. Now we are on the AWS Lambda console. As you can see, the Lambda layer has been published successfully. Now let's go to the S3 bucket and see what files have been uploaded there. Let's download these files and see what's in there. The packages.zip file contains the libraries that were packaged into the layer. As expected, there are two NuGet packages in this Lambda layer. Now that our layer is published, let's go ahead and publish the Lambda function. Notice the function layers parameter where I'm supplying the ARN of the newly created Lambda layer. The Lambda function has been published successfully. Let's go to the Lambda console to see the details. Now we are on the Lambda console and let's click on the Lambda function we just created. As you can see, there is a layer associated with it. When you click on the layers, you can see that the layer that we created called demo layer is associated with this Lambda function. Let's check the S3 bucket that contains the Lambda function code. As you can see, the zip file size is really small, and we're going to download this file and see what files are inside. As expected, the only DLL that is present is demolayer.dll, and the only other one is newtonsoft.json.dll, which we did not package into a Lambda layer. So the overall package size is really small. Let's go ahead and test the function using the .NET Lambda CLI invoke function command. I got the uppercase converted input string as response. This means the function is working successfully. Thanks for watching this video. Happy coding!